Hello friends, welcome to Daring Marine YouTube channel. So we will be discussing about some basics in naval architecture, some terms and all. So let's discuss what is freeboard of ship and why tankers are having less freeboard. Okay. Freeboard is the vertical distance from waterline to the uppermost continuous deck. Okay, it is the vertical distance from waterline to the uppermost continuous deck. If there is no freeboard, the deck will be on waterline. Okay, if there is no freeboard, the deck will be on waterline. Freeboard of the ship is the vertical distance from the waterline to the uppermost continuous deck, which is known as freeboard deck. If there is no freeboard, deck will be on waterline. A certain freeboard is required for safe sailing of ship, otherwise water may enter into deck. A certain freeboard is necessary for the safe sailing of ship, otherwise water may enter into deck. Every ship should have statutory freeboard and providing an insurance against merchant ship being lost. Every ship should have statutory freeboard and providing an insurance against merchant ship being lost. Freeboard depends on length, block coefficient, displacement, shear pattern, type of ship, etc. The freeboard depends upon length, block coefficient, displacement, shear pattern, type of ship, etc. If ship is sailing on bad weather region, freeboard will be high. If ship is sailing on bad weather region, freeboard will be high. A certain freeboard is required for safe sailing of ship, otherwise water may enter into deck. Every ship should have statutory freeboard and provide insurance against merchant ship being lost. Freeboard depends on length, block coefficient, displacement, shear pattern, type of ship, etc. If ship is sailing on bad weather region, freeboard will be very high. Minimum freeboard is marked on ship side of ship, which is known as load line or plimsoll line. Minimum freeboard is marked on ship side of ship, which is known as load line or plimsoll line. Why tankers are having less freeboard? The reasons are: tankers have much smaller deck opening in the main deck. The tanker will be having much smaller opening in the main deck. Tanker have a great subdivision by additional longitudinal and transverse bulkhead. The tankers will having great subdivision by additional longitudinal and transverse bulkhead. Tankers normally carry lesser density cargo, that is, they have greater buoyancy. Tanker normally carry lesser density cargo, so they have greater buoyancy. And tankers having greater metacentric value, GM value. Okay. Okay, that means why tankers have less freeboard means tankers have much smaller deck opening, in main deck, and tankers have greater subdivision by additional longitudinal and transverse bulkhead. Tankers normally carry lesser density cargo, that is great buoyancy, and tankers having greater GM value. So, principle of flotation, Archimedes principle, buoyant force, then how ship floats. These are some of the basic principles that we need to understand as a naval architecture, some basics. So, let's discuss about these topics. Buoyant force is when a body placed in a fluid, the fluid will exert an upward force, which is known as buoyant force. When a body is placed in a fluid, the fluid will exert some force on the body, that is known as buoyant force. Buoyant force is the pressure exerted on the body by fluid. Buoyant force is actually a pressure exerted on the body by fluid. The pressure increases as depth increases, and pressure on both bottom of object is always larger than force on the top. So net upward force is larger at bottom. Okay. So it means pressure increases as depth increases. Pressure on the bottom of object is always larger than force on the top. So net upward force is larger at the bottom. Archimedes principle. As per Archimedes principle, that means upward buoyant force exerted on a body in fluid, whether fully or partially submerged, is equal to weight of fluid that body displaces. That means buoyancy will be equal to weight of displaced fluid. Archimedes principle states that upward buoyant force exerted on a body in fluid, whether fully or partially submerged, is equal to weight of fluid that body displaces. Buoyancy will be equal to weight of displaced fluid. If weight of water displaced is less than weight of body, then body will sink, otherwise body will float. If weight of water displaced is less than weight of body, then body will sink, otherwise body object will float. How ship floats? That means principle of flotation. When a body displays weight of water equal to its own weight, it floats. This is known as principle of flotation. That means if a body displays weight of water equal to its own weight, then it will float. This is principle of flotation. A ship displays weight of fluid equal to its own weight. A ship will displace weight of fluid equal to its own weight. Every ship must be designed to display weight of fluid equal to its own weight. Every ship must be designed such a way that it will displace weight of fluid equal to its own weight. Here TPC, tonnage per centimeter immersion. So let us discuss about this TPC, tonnage per centimeter immersion. This is the mass that must be added or removed from ship in order to change the ship draft by value of 1 centimeter. It is the mass that must be added or removed from ship in order to change the ship draft by value of 1 centimeter. This TPC varies with the draft and water density. This tonnage per centimeter immersion that will varies with draft and water density, and this tonnage per centimeter will helps us to know draft of different loads. Tonnage per centimeter will help us to know draft at different loads. Tonnage per centimeter is equal to A into D by 100. A means area of water plant at certain draft. A equal to area of water plant at certain draft. D density of water in which ship floats. Okay. Tonnage per centimeter immersion TPC equal to, this is the mass that must be added or removed from ship in order to change ship draft by value of 1 centimeter. This TPC varies with draft and water density. This TPC will help us to know draft at different loads. TPC equal to A into D by 100. A means area, D density. Okay. Coefficient of form and its significance. Coefficient of form and its significance. Coefficient of form are used to understand shape or configuration of ship and dimension of ship. These are dimensionless quantity. Coefficient of form are used to understand shape or configuration of ship and dimension of ship. These are dimensionless quantity. Water plane coefficient. Water plane coefficient means it is the water plane area divided by multiplication of length and breadth. Water plane coefficient is equal to water plane area divided by multiplication of breadth into length. AW by B into L. Water plane coefficient. That means high water plane coefficient indicates good stability, good maneuverability in rough condition and high friction resistance. High water plane coefficient means good stability, good maneuverability in rough condition and high friction resistance. Low water plane coefficient indicates low friction resistance and fine ends. Low water plane coefficient indicates low friction resistance and fine ends. Okay. Water plane coefficient means it is the water plane area divided by multiplication of breadth and length. That means CW is equal to AW by breadth into length. High water plane coefficient indicates good stability, good maneuverability in rough condition, high friction resistance, etc. Low water plane coefficient indicates low friction resistance and fine ends. Midship coefficient CM. It is the cross sectional area of underwater portion of midship section to product of breadth and draft. It is the cross sectional area of underwater portion of midship section to product of breadth and draft. CM is equal to AM by breadth into draft. Then it gives idea of shape of ship at the midship. It gives idea of shape of the ship at midship. Cargo vessel having boxy shape at midship because of high CM, whereas sail ship have low midship coefficient. Okay. Midship coefficient means it is the cross section area of underwater portion of midship section to product of breadth and draft. CM is equal to AM divided by breadth into draft. This midship coefficient gives idea of shape of ship at the midship. Cargo vessel having boxy shape at midship section, whereas because of high midship coefficient, and whereas sailboats will have low midship coefficient. Block coefficient. It is the ratio of volume displaced by ship to product of length, breadth and draft of immersed portion of ship. It is the ratio of volume displaced by ship to the product of length, breadth and draft of immersed portion of ship. CB is equal to delta divided by L into B into T. Here underwater volume of ship are calculated using this block coefficient. Underwater volume of ship are calculated using block coefficient. Tankers having high block coefficient, passenger vessels having lower block coefficient. Okay. Block coefficient means it is the ratio of volume displaced by ship to product of length, breadth and draft of immersed portion of ship. CB is equal to delta divided by L into B into T. Underwater volume of ship are calculated using block coefficient. Tankers having high block coefficient. The tankers will having high block coefficient, whereas passenger ship will have lower block coefficient. Prismatic coefficient. Prismatic coefficient means it is the underwater area divided by area of midship section and the length of ship. It is the underwater area divided by area of midship section and the length of ship. CP is equal to delta divided by AML. Okay. That means volume of displacement divided by area of immersed portion of midship section into length of immersed portion. So relation between CP, CB and CM is CB is equal to block coefficient is equal to prismatic coefficient into midship coefficient. CB equal to CP into CM. Okay. Okay, center of gravity, center of buoyancy, and meta center of ship. Okay, let's discuss about this some topics. So these are some basic terms. So we need to understand have some idea. Center of gravity means weight of ship is distributed all over its length and is acting downwards. You have to understand that the weight of ship is distributed all over its length and it is acting downwards due to gravity. We can consider that all weight of ship is acting downward through a single point, which is called a center of gravity. If we consider all the weight of ship is acting downward through a single point, which is called a center of gravity, we can say that weight of ship acting downward through one point is known as center of gravity. Center of gravity of ship can be calculated by inclination experiment. Center of gravity of ship can be found out using inclination experiment. Center of gravity means weight of ship is distributed all over its length and is acting downward. We can consider that all weight of ship is acting downward through a one single point, which is called the center of gravity. We can say weight of ship acting downward through one point is known as center of gravity. Center of gravity of ship can be calculated through inclination experiment. Center of buoyancy. When a ship is placed in a fluid, the fluid exerts an upward force, which is called buoyant force. Center of buoyancy is the point at which all buoyant force acts upwards. Center of buoyancy means when a body is placed in a fluid, the fluid exerts an upward force, which is called buoyant force. Center of buoyancy is the point at which all buoyant force acts upwards. Center of buoyancy is the center of immersed part of ship hull. Center of buoyancy is the center of immersed parts of ship hull. If vessel is floating upright, center of gravity and center of buoyancy are the same line. If a vessel is floating upright, that means center of gravity and center of buoyancy are the same line. Center of buoyancy means when a body is placed in a fluid, the fluid exerts an upward force, which is called as buoyant force. Center of buoyancy is the point at which all buoyant force act upward. Center of buoyancy is the center of immersed part of ship hull. If vessel is floating upright, center of gravity and center of buoyancy are in same lane. Metacenter. It is the lane drawn through center of buoyancy of a floating vessel and corresponding lane through new center of buoyancy when the vessel is tilted. It is the lane drawn through center of buoyancy of a floating vessel and a corresponding lane through new center of buoyancy when the vessel is tilted. Thank you.